Hello everyone, I hope you all are doing really well. Saboni again this side. In this new video, I'm going to show you how you can instrument your application using Prometheus client library and then use Prometheus to scrape those metrics from your application and how to use Grafana for comprehensive monitoring and observability. So all this setup has been done locally. You can test it out locally using simple Docker images and using Docker Compose to bring those applications up and running. So it's demo time. Before proceeding with the demo, it is important for us to know what is Prometheus. So observability is a key aspect of any application to understand what is happening within your application or how your application is behaving whenever there are increased load or with variations of load. So three critical important metrics of observability is logs, metrics, and traces. So metrics for logs and traces, you will have different other options, but the scope of this demonstration and this video is more about metrics. And if we talk about metrics, Prometheus comes as a leading name here. So what is it? So it's an open source system monitoring and alerting toolkit that provides you with the capability to store your metrics as time series data. So Prometheus has the capability of collecting and storing the metrics that of your application or of your environment in the form of a time series data. So critical component of Prometheus, if we talk about, is the architecture. If you specifically focus on this is a Prometheus server. So Prometheus server has three components. One is a retrieval component, the other is a time series database, and the other one is the HTTP server. And it has a node level storage. The other capability includes, so what Prometheus generally, the retrieval part it does is, you can create jobs or there are certain exporters from where this retrieval part component would retrieve the metrics in pull format. In a pull basis, in a pull mode, it generally works. So on the basis of some time that you specify at certain interval, it will do the polling of those scraping of those metrics. There's another way where you can feed the Prometheus server with your metrics, which is through the help of push gateway. So if there are certain short-lived jobs that is not generating metrics all the time, but at certain interval of time, you can use push gateways. From there, again, Prometheus server would retrieve those metrics for you. Talking about how you can query those metrics or observe it. So Prometheus provides you with something called PromQL. So it is a Prometheus query language, and that you can run through Prometheus web UI as well as the Grafana dashboard or through any other API clients. So this is just an overall overview of like how Prometheus works. So this is the setup that I'm going to test it locally. So on the left side, you can find a Flask application with instrumented Prometheus client. And the second, in the middle, you will find the Prometheus instance, which is configured with a scraping job, which is continuously scraping at regular interval, trying to get more metrics, trying to get the metrics out of your Flask application that you're exposing. And on the extreme right, you will find a Grafana instance that is connecting to the Prometheus. So the Prometheus is acting as the data source, metric source, and the Grafana is used to visualize those metrics. So talking about this project structure, it is available in my GitHub account, and the link I have already shared that in the description. So it has two folders primarily. One is the app, and the other one is the local. So talking about app is where my application, Flask application, resides. Application you will find exposes three API endpoints. One is /root, which just returns a healthy OK response. The other two are one is a delayed response, just mimicking any delayed API response. In this case, added by time.sleep of 1 second. I'm adding over here, and there's another route which is /error that raises an exception. You will find a lot of additional decorators are being used in addition to the route. So the first thing is the use of a Prometheus client library. So here in the requirement.txt, you need to pass the Flask version as well as the Prometheus client version, the latest ones, please. And once you use that, so Prometheus provides you with certain default metrics, which is the counter, histogram, gauge, and summary. So in my example, I've just used counter and histogram. So in the public documentation of Prometheus, you will find those definition of what each of those metrics signifies. So counter is basically a monotonically increasing metric number. So if it denotes the application request total over a course of time. And histogram, it takes the snapshot of a specific metric that you want to store. So for example, number of requests that took less than 5 seconds, less than 1 millisecond. If you want to capture that kind of information, request latency, you can use a histogram type of metrics for capturing that. So there are three methods that comes along with this application. So you can see one is before request. So these are the certain decorators that you can use in your Flask application to note or to perform any operations before you. So whenever you make a request to an API call, before that, these section of codes get executed before request, and after that API after that route has returned this response. For example, in that case, if you want to execute something after that, then after request is something you need to use. So before request is capturing the time, and after request you can see it is calculating the time taken to fulfill that request. And it is also incrementing the router by 1. So here you can see in the request count, it's adding these levels of method, endpoint, and the response, and just simply increasing it by 1. And the request latency, it is also taking the observation of the time difference between the start time of the request and the current time where the request has been processed. Additionally, there is another error handler decorator that has been added over here, which adds the level of method, endpoint, and the exception type, and it is also incrementing by 1 since it's a counter. So whenever there is an exception, so whenever you would try to access the /error path, an exception would be raised. It would be captured by this handler class, handler method, and accordingly the error count would increase and you will get a response. So now in the local folder, I would like to show you, I have used Docker Compose YAML. Here you will find 3 services. One is the app services, where it is denoting the application, the Flask application that I'm running. And the other 2 is, one is the Prometheus, another is the Grafana. So these 3 servers, these 3 container instances would run simultaneously in my local account, in my desktop. And through Docker Compose, I have used it to bring up those container instances. Now, one important thing to observe is, so there is a prometheus.yml file, which I'm mounting it to the container instance. And what does this file contain? So it contains the scraping configuration. At regular interval, what is the target that Prometheus instance will try to consume? So by default, it tries to consume the /metrics path. So if I again show you over here, app.py, this is the route it is trying to access. And it publishes all the metrics. So if I come over here and in the Docker Compose file, I'll just click on Compose Up. So since I'm using Docker plugin in my Visual Studio Code, I'm getting those options quite easily, but there's a simple command of using Docker-compose up. In that case, your all container instances would be up and running, provided you have Docker installed in your machine. So I'll just go over here, sorry. So now I will just go to my Docker desktop. So here I will find 3 applications are up, 3 container instances are up, which is Prometheus 1, App 1, and Grafana. Now I will go to this endpoint, and if I click on /metrics, I will observe that there are a lot of informations that are coming up about the different types of metrics that Prometheus will have access to. So it will try to scrape through this API endpoint, and it will get information about the metrics which my application is exposing. So if I try to again access the other endpoints, which is the /route and delay, I'm getting a delayed response, and for error, so I'm getting error handled. Now in order to observe that the metrics are being pushed, I'm going to perform a performance test, a load testing on my application, and I have used this open source tool called Hey. So Hey can be easily installed on Mac using brew install. For other systems that you are using, so there are links that are available, you can use them. Now going back over to here with this performance test script that I have used, I've just specified the endpoints, I have specified the request, total request counts, and a concurrency value, and this is my base URL. And what it is doing is, it is by endpoint is picking up one endpoint through this set of endpoints that I have specified, and it is just invoking this command, which is hey-n followed by the request and the concurrent count for that specific endpoint. So let's start performance test. The beauty of tool Hey is that you will get a response you will get a proper response of what is the fastest, what's the average, what's the slowest response, what is the request number of requests per seconds, the total request size, and you will get a response time histogram as well to understand, and this will give you an understanding of how much time it took. It also gives a latency distribution of how much time it took for 99%, so it's a P99 if you want to measure, so those informations are also available over here. Now as you can see that the performance test has been completed. I'll just go to the Prometheus UI. So using Prometheus UI you can actually see understand like what is the metrics as well. It provides you with a default visualization mechanism. So if I just search for request total, so you will find that for metrics, for health, for delay, there are API calls that has taken place, like based on the performance results, you will find that there are metric counts available. You can easily visualize it through graphs, and this is what you get to see over here. So the same visualization could be implemented through Grafana as well. So if I go over here, and by default, so over port 3000 my Grafana instances is up and running. I'll just go over here. Admin is the user and admin is the default password, so it asks you to update the password. So once I have done it, I'll just go over here, and in the connections, under connections, I need to search for Prometheus. So this is what the Prometheus you need to select, and over here you just need to add the endpoint. So you will find that HTTP Prometheus :1990. So that this container instance of Grafana would be able to understand which container instance to communicate, because underneath, since I'm using Docker Compose, and underneath that bridge network, service discovery is already taken care of by Docker. So if I go over here, I'll add a visualization based on the source I select. So here I can see that my app request count. So along with that, the app request, the custom errors, the custom metrics that I have, that my application is publishing, along with that there are additional containers, the application container specific metrics are also available. So if you want to see the app error total, you just run the query and you will see that it is available. And along with that, if you want to add any additional queries, say for example CPU, you just run this. You might not be able to observe it because of the app error total count value is more, so you just need to hide that response. And you see at this point of time the performance test I just conducted, and there's a spike in the visualization. So you can just save this dashboard using test, and if you go back to the dashboard, by default you will find that as you have saved it, it's available over here. So organization can easily organizations can rely on these dashboards on us. It would provide them with a single glass pane, and from here you can visualize different parameters of your applications that you want to see. So this entire code is available in my GitHub, the code as well as the Docker Compose file, and I have already shared that in the description link. Go through it, and if you have any questions, if you have any concerns, just let me know in the comment section. I hope you liked this video and hope you have enjoyed it, and hope you will enjoy it, and let me know if you have any queries. I'm wishing you a great day ahead. Cheers. Bye-bye.